In this question, it is given that two charged particles A and B carrying a charge of capital Q are placed at a distance d. If CD is a perpendicular bisector of AB, so in the first part we have to find the electric force if we displace by a distance x. So here CD is x and we have to find the force at D. So if we make a, so FA is repulsive in nature, FB is repulsive in nature. The distance of AD is considered as R and the distance of BD is considered as R. So if we make a component with respect to x-axis and y-axis, this is theta. So we can write it as FA cos theta, FA sin theta, FB cos theta, FB sin theta. So in this question, FA is equal to K capital Q small q by R square, FB capital Q small q by R square. So we can say that FA is equal to FB is equal to F. So with respect to x-axis, both the force will cancel out because force is same and they're in the opposite direction. So net force is equal to FA sin theta plus FB sin theta. It's equal to 2F sin theta. Now we substitute the value. F dash is equal to 2 into K capital Q small q by R square. Sin theta is x by R. So it is equal to 2 into K capital Q small q by R cube. We can write it as 2 into 1 by 4 pi epsilon naught capital Q small q. Here R is equal to root of x square plus d square by 4 if we are using in triangle ACD by using Pythagoras theorem. X square plus d square by 4 to the power 3 by 2. This is the answer for the first question. In the second part of the question, it says that when the x is very small with respect to the d, how we can show that force is proportional to x. X is very less to d. So F dash we know it is equal to 2 capital Q small q divided by 4 pi epsilon naught x square plus d square by 4 3 by 2. So we can write it as 2q capital Q divided by 4 pi epsilon naught d square x square by d square plus 1 by 4 to the power 3 by 2. So when x is very less than d, it means that x by d is approximately 0. So f dash is equal to 2 capital Q small q divided by 4 pi epsilon naught d square to the power 3 by 2. Here x. So we can write 2 capital Q small q into x by 4 pi epsilon naught d to the power 3. So here small q capital Q all are constant. Only x is varying. So f dash is directly proportional to the x. This is the answer for the second part. In the third part, under what condition will the particle C execute SHM if it releases from a small displacement, and find the time period. So for SHM, F must be equal to m into omega square into R. So if you substitute the F dash value, this is our F dash value. So we can write it as 2 into capital Q, a small q, x divided by 4 pi epsilon naught d to the power 3 is equal to m into omega is equal to 2 pi by t into x. So here x cancel. This is whole square. So when we solve it, we will get it as t is equal to m pi to the power 3 epsilon naught d to the power 3 divided by capital Q, a small q to the power 1 by 2. This is the answer.